Hello students, hope you all are doing well. I welcome you all in my YouTube channel DOSEOPEDIA. Today we are going to discuss about the empirical formula and the molecular formula of organic compounds. Let's start with the empirical formula, students. So in the organic compound, right, different formulas are there. One is the empirical formula, then next one is the molecular formula, then next one is the structural formula, right? And the structural formula can also be written with the different types. Okay, so in this different formulas, we have to start with the empirical formula first. So what is the empirical formula, students? The empirical formula of a compound, it is the simplest formula from all these formulas, right? Molecular formula, structural formula, okay? From all these formulas, this empirical formula is the simplest formula of organic compound, which express the percentage composition. So what is the use of empirical formula, right? Empirical formula will represent the percentage composition, okay? It means what? It means that this formula tells us the ratio of the atoms, right? It will tell us the ratio of the atoms of different elements which are present into the molecule, right? So it will not tell us the actual number, right? It will not tell us the actual number of atoms of each element present in it, students, right? But what it will tell us? Just the percentage composition, percentage ratio of all the atoms, all the elements which are present in the specific organic compound, okay? So, how we can calculate this empirical formula? Let's go for the steps. Calculation of empirical formula. So, this process is divided into 3 steps. How many steps, students? This process is divided into 3 steps. Very first step is what? The percentage of each element is divided by its atomic weight. So what you will need here? You will need atomic weight of an atom. So how you can have this atomic weight? So for that, you should memorize the periodic table, okay? And in this periodic table, you have given with the atomic number as well as atomic weight of each and every atom, okay? So first of all, go for the periodic table and memorize the all atoms atomic weight as well as atomic number, right? Because to calculate the empirical formula, you will need the atomic weight. So whenever you will divide the percentage of an element by its atomic weight, then you will have a specific number, right? So this will give you a relative number of different kind of atoms in the molecule, okay? So this is very first step. Now the second step is what? That the numbers you have obtained from step 1, right? Whenever you have divided the percentage of the specific element by its atomic weight, then you will have a specific number. Now this specific number should be divided with the percentage which is the very least percentage of the element, right? So the numbers obtained are then divided by the smallest number, okay, of the percentage given of atomic ratio. And the last step. So now you have again some numbers, right, in the step 2. So these numbers, right, these figures will express the simple atomic ratio, right? Okay, so it will give you the number of atoms of each element in the molecule, okay? Now, do you want to calculate with an example? Yes, let's go for that. So this is the example for the calculation of empirical formula, okay? So we have here an organic substance. On analysis, it was found that it contains 10.06% of what? Carbon. 0.84% of hydrogen and 89.10% of chlorine. Okay. Now, how we can calculate the empirical formula for this particular organic substance? Let's do it. First is divide the percentage composition of each element by its respective atomic weight, right? So first of all, you should know about the atomic weight of carbon, atomic weight of hydrogen, and atomic weight of chlorine, right? So what is the atomic weight of carbon? That is 12. Atomic weight of hydrogen, that is 1. And atomic weight of chlorine, that is 35. Right? Now, let's divide the percentage with its atomic weight. So, very first is carbon and its percentage are 10.06. And we have to divide this percentage by the atomic weight of carbon, that is 12. Okay. So, calculate 10.06 divided by 12. What will be the answer? The answer will be 0.84. Right? Now, let's divide the percentage of hydrogen by its atomic weight. So, for hydrogen, 0.84 divided by 1 is equal to 0.84 itself. Right? And for chlorine, let's divide its percentage, that is 89.10 divided by 35, and the answer will be what? 2.51. Okay, so this is very first step. Now let's go for the second step. So what is the second step? Divide these numbers by the smallest number in the means of percentage, right? The least percentage of the element given in the organic compound. So let's divide it. For carbon, 0.84 divide by, what is the least percentage here? It is again 0.84. So let's divide by 0.84. So answer will be 1. Okay. For hydrogen, again here it is 0.84. So let's divide it by again 0.84. So the answer will be 1. And for chlorine, 2.51, which will be divided by 0.84. So your answer will be around 3. Okay. Now we have the numbers, right? 1, 1 and 3. So what is this? This is the composition ratio of the particular organic substance, right? So we can write now the empirical formula of this substance, right? So carbon will be 1, hydrogen will be 1, and chlorine will be 3. Okay. So we can write the answer, the empirical formula, that is CHCl3, because carbon and hydrogen are in the ratio of 1:1 and chlorine is in the ratio of 3. So 1:1:3. So we can write the empirical formula for this organic substance as CHCl3. For this type of other examples, you can comment me in my comment box that if you want to solve this type of examples of empirical formula and molecular formula, then in upcoming videos I will have some examples more for the empirical formula as well as the molecular formula. Now we have seen what is empirical formula. Now let's go for molecular formula, right? So as we have discussed in the empirical formula itself, that empirical formula is giving us the percentage of particular elements present in the organic compound, right? But the molecular formula is opposite to that. Empirical formula does not give us the actual number of the elements present in the organic compound, but molecular formula give us the actual number, right? It will give us the actual number of atoms of each element present in the molecule. So this is the difference between empirical formula and molecular formula. Empirical formula does not give you the actual number of element present in the molecule, while molecular formula give you the actual number of elements present into the particular compound. Okay. Now, in some organic substance, empirical formula can be equal to molecular formula. Let's have an example, like methane. Okay, so what is methane? Methane is one carbon that is connected with 4 hydrogen. Okay, now here only one carbon, right, which is connected with the 4 hydrogen. So this is the empirical formula also for methane. This is the molecular formula also for methane, right? So in the case of methane, the empirical formula is equal to molecular formula. But for all the compounds, this is not correct. Okay, so for the ethylene, okay, that is alkene. Okay, for that, the molecular formula and empirical formula both are different. Let's say you have ethylene, right? So carbon is double bonded with carbon, okay, because here the ethylene, eth is the prefix, so 2 carbon will be present in your compound, and as the carbon is containing 4 valency, okay, so carbon can make another 2 bonds with another atom. Okay, in the case of ethylene, this 4 will be hydrogen, right? So now let's count. How many carbons are there? 1 and 2. How many hydrogens are there? 1, 2, 3 and 4, right? So your molecular formula will be C2H4. Okay, but if we have the ratio, percentage ratio of C2H4, then we can write it as CH2. Okay, so in the case of ethylene, the empirical formula will be CH2, but molecular formula is C2H4. Okay, now let's have an example of acetic acid. Okay, so what is acetic acid? As here you have suffix acid, okay, so it can be the carboxylic acid. Okay, so the acetic acid formula is CH3COOH. How many carbons are present? 1 and 2. So C2, how many hydrogens? 3 plus 1, 4. And how many oxygens? 2. So its molecular formula will be C2H4O2. Okay, and if you have the percentage ratio of acetic acid's molecular formula, that is C2H4O2, so we can convert it into CH2O, right? Because carbon is 1, oxygen is again 1 in the percentage ratio, and hydrogen is double. Okay, so 1:2:1 is the composition for the acetic acid for carbon, hydrogen and oxygen. Next is glucose. Okay, so glucose is having the molecular formula C6H12O6. All you know, right? The molecular formula of glucose, that is C6H12O6. And when we convert it into the percentage ratio, okay, so it will be 1:2:1, right? So again the empirical formula for glucose, that is CH2O. Okay, now students, if you want to relate, right, between the molecular formula and empirical formula, right, then we can write one equation. And what is the equation? Molecular formula is equal to the empirical formula, okay, is multiplied by n, when the n is the number of element. Okay, molecular formula is equal to empirical formula by n. Okay, now let's find out from this equation empirical formula. Okay, so how to find the molecular formula of the compound from empirical formula. It means that you have empirical formula. From empirical formula, you have to find out the molecular formula of compound. So for that, again, we have one equation. The equation is molecular weight is equal to empirical formula weight into N, where N is the number of elements. Now, as we have seen just in the previous slide, that molecular formula is equal to empirical formula multiplied by number N, right? So we have to find what? N, right? So N will equal to molecular weight of compound divided by empirical formula weight. Okay, by using this equation, we can easily have the N numbers. Okay, let's see with the example. An organic compound has been found to possess the empirical formula CH2O. So you are given with the empirical formula CH2O. Its molecular weight is also given, that is 90. Now give its molecular formula. So to find out its molecular formula, we should have N, right? And also we should have molecular weight and empirical formula weight. So molecular weight is given to you, that is 90, but we have to find what? Empirical formula weight. So let's find it out. For CH2O, the empirical formula weight is equal to atomic weight of carbon, that is 12. Atomic weight of hydrogen, that is 1, but here there are 2 hydrogens. So it will be 2. And atomic weight of oxygen, that is 16. So if we do the summation of all these 3, then it will be equal to 30. Okay. Now let's put these values in this equation. Okay. So N is equal to molecular weight 90 divided by empirical formula weight, that is 30. So what will be the answer? The answer will be 3. So we have to put N is equal to 3 in the formula of molecular formula. So molecular formula is equal to empirical formula into N. So we will have CH2O multiplied by N, that is 3. So you will have C3, 3 2s are 6, so H6, and oxygen is 3. So C3H6O3 will be the molecular formula of compound. But this is not a structural formula, students. This is the molecular formula. Why is it so? Because many compounds are there whose molecular formula is the same, but structural formula will be different, right? So it will give you the different compounds that are called isomers. Okay, so here it is the molecular formula only. Now we have done with the molecular formula and empirical formula. Let's go for some MCQs, okay, that can be asked in your exam. So very first question is, the empirical formula for ethane is what? So ethane, okay, ethane, it is an alkane. So alkane is having one general formula, that is CnH2n plus 2. Okay, now here we have the prefix, that is eth, right? So these all are actually the rules of nomenclature, okay, for organic compounds. So the rules we will see in the upcoming lectures. But for now, eth is equal to carbon number 2, right? So how many number of carbons will be present in the ethane? 2. So let's put it, N is equal to 2. So C2H2 2 plus 2. So 2 2s are 4 plus 2 is 6. So it will be C2H6. Now, if you want to convert this molecular formula in its empirical formula, so we have to convert it into its percentage ratio, right? So it will be CH3. Okay, but here from all these 4 options, CH3 option is not there, right? But actual answer is what? CH3. Okay. Now, the next question is the molecular formula for propanol. Okay, now what is this propanol? This is again the new name. Okay, so propanol, it is an alcohol, right? As you have the suffix ol, okay, which represents alcohol, plus you have prop as a prefix. So as in ethane, eth is the prefix, so eth is equal to number of carbon will be 2, and in the case of prop, number of carbon will be 3. So here number of carbon is 3, right? Now let's arrange the 3 carbon and 1 OH group, right? Because it is an alcohol. So the general formula for alcohol, that is ROH. OH is the functional group for alcohol, right? Now R will be alkyl group. How many carbons are? 3 carbons are here, right? So let's arrange 3 carbons. 1, 2, 3. And you have OH that is attached with 1 carbon. Now, as you know, students, that valency of carbon is 4. Okay, now let's arrange the hydrogens in this particular equation. So carbon, it is attached with 3 carbon as it is the terminal carbon. Okay, so this carbon's 4 valency are fulfilled. 1, 2, 3 and 4, right? Now for this carbon, 2 hydrogens will be attached over here. 1, 2, 3, 4 valency. For this carbon again, 2 hydrogens. 1, 2, 3 and 4. So all the 3 carbons, 4 valency is fulfilled. Oxygen has 2 valency, so oxygens in making one bond with this carbon and the another bond with this hydrogen. Okay, so this is the structural formula, as well as you can say the molecular formula for what? Propanol. CH3, CH2, CH2OH. And if you want to write in the numbers, then C3. Hydrogens are 1, 2, 3, 4, 5, 6, 7, 8. So H8, and oxygen is 1. So C3H8O is the molecular formula for propanol, right? Here it is given in the case of this type of structure, CH3, CH2, CH2OH. So 3 carbons are present only in this option with hydroxyl group. So this will be the right answer for propanol. Okay, students. So I hope you all are enjoying my lectures of organic chemistry. If you have any doubt or if you want any particular topic, right, in the organic chemistry, then you can write it into the comment box. So I will try to record the lecture on that particular topic. Okay, students, have a nice time. Thank you.